Grab your notes and let's talk about pseudoscience. What do you know about, well, first of all, about the prefix pseudo? You know what that means when you put it in front of something? Fake. Good. Fake science. And it's even more than that. When we say pseudoscience, what we really mean is not only is it not science, because lots of things are not science that are great. Not everything has to be scientific. The problem with pseudoscience, and the reason we teach about it, is pseudoscience is not only not science, but it is claiming to be scientific. And this is an important part of this unit because you are flooded with pseudoscience every day. Mostly, where does the pseudoscience you're exposed to every day come from, do you think? Yeah. Yeah, a lot of it does come from the internet, absolutely, but some from things like TV, billboards, magazines. Most of it has one thing in common, though. Most pseudoscience is trying to get you to do something. Guess what? What are most pseudoscientific things on the internet? What are the claims you see made on the internet typically? Huh? Huh? And what do they want you to do? It's an ad. Most pseudoscience you're exposed to comes from ads. Not all, but most. So my goal here is to get you to kind of develop your own, let's call it a BS detector. Okay? I want you to build up part of your brain into what we're going to call a BS detector, where when you see certain clues, and clue number one, I'm not even putting down there because I think you know it already. If they're trying to sell you something, immediately your BS detector should go off. Because they're allowed to say pretty much anything, including that this is scientific, that it's scientifically proven to work. I don't know why they're allowed to say that, but they are. You shouldn't believe it. They have an ulterior motive. They're trying to get money. Don't trust them. That's good number one. But there's lots of other trickier things that I want to teach you about so that you develop your BS detector into something that can really help you be a better consumer and citizen. And when I say BS in BS detector, you know what I mean, right? Bad science? That's what you were thinking? Okay, I'm just making sure. Good. So we're actually going to only spend today on one pseudoscience clue because it's so important and kind of it takes so many examples and it's so frequently misused. Let's start with this. Take that in for a sec. That's a graph. Do you know what it means? I mean, it's just scribbled on notebook paper, right? But that graph, even without numbers, it tells a story. Every graph tells a story. What story does that graph tell? We've got an axis here that says times a book is banned, and then one here, the y-axis, kids who want to read it. What does that mean? Right. That tells you that as one thing increases, that slanty line this way tells you that the one thing goes up and the other also goes up. It means that the more times a book is banned, the more likely kids are to want to read it. Do you think that's true? If the data that went into that graph is real, then it is true that there is. Did anybody know the name of that relationship? When we show a graph like that, we call it a positive. Very good. Correlation. But the way you said it, when you said it, made me think maybe you were starting to think something else besides correlation. You said something like, well, the more times the book is banned, the more kids want to read it. And that's starting to make me think that I wonder if it's the fact that the book got banned itself that's making the kids want to read it, right? That's different than correlation. That's what we call causation. And they are very different. One is real easy to prove, the other one's real hard. Here's another one, a little closer to home. It's another real one. There is a positive correlation between the average wealth of Ohio families and the drowning deaths per family. So, obviously, you came to the same conclusion I did already, which is the obvious one that rich kids can't swim. Right? It's because they get spoiled their whole lives, and their parents don't make them learn how to swim. They don't make them do anything, so they drown more easily, obviously. Now, you guys are chuckling like I'm an idiot. You're right. But, okay, fine. If it's not that, what is it? And this is the challenge. And you ought to, I really want your brains to start working this way to where because you're going to hear correlations on the news all the time about, well, this thing is associated with risk of heart disease in men. And I want your brain to immediately go to, okay, well, you're implying that causes heart disease, but what else could be going on? So what else could be going on here besides rich kids can't swim? What do you think? Ooh, I like it. He said the richer people are, the more pools they have. Okay. What else you got? I like both of these very much. Yes, pools cost money, and that's one way to get access to water, which would increase your risk of drowning. But also, if you got enough money, you can get out of Ohio for a while, go on vacation. Maybe to the Great Lakes. You got a little bit of money. Maybe to one of the coasts, California, right? North Carolina, if you got a little more money. Shoot, maybe going to the French Riviera. They're really loaded, right? Yeah, I think that's it. Because Ohio, man, we're landlocked. And we don't have any natural lakes except for the great ones to the north, right? Any lake you see around here is fake. And they dam a river and make a recreational lake. But yeah, access to water in Ohio especially costs money. And so rich people are more likely to have access to water, which makes their risk of drowning throughout the whole family absolutely go up. Good work. You're going to be good at this. Here's one even closer to home. It's not even a slanty line. You can see the correlation nonetheless. And I can tell you this is true. I'm the one who made this graph and made these observations, that there absolutely is a correlation between test days and bathroom visits. Way more kids go to the bathroom on test days. So obviously thinking harder than normal makes you have to poop and pee. Right? Okay, chuckle, but then give me what you think the real. I actually don't know this one. I've heard lots of good ideas, but what do you think? Why is this correlation real? Because it is. I know sometimes when I get nervous, my bowels start moving. Maybe it's nerves. Maybe nerves get the old pipes moving, and that's what's going on. Kind of what he said, yeah. Uh-huh. Ooh, so before a test or during a test, maybe it's that they want to cheat. I like it. Yeah. Although I can tell you almost all of the bathroom visits are post-test. Yeah, or after the test. That's a good thought. Anything else? Yeah. Yeah. Time to decompress. I think that might be close to that might be one of the bigger reasons is like you're in this room, you're stressed out, you can feel everybody's stress. That's real. And getting out, just think of it as taking a walk instead of going to the bathroom. Maybe that helps you de-stress. Yeah, good. Awesome. So, here's the deal. Ignore the drawing for now, even though it's super weird. We'll get there. I promise it'll make sense. Using correlation to imply causation is your big pseudoscience clue today. Because it turns out it's real easy to prove correlation. It is very difficult to prove causation. Most of the time, you'll see this confusion happen with what we call observational studies. Observational studies are when we're not allowed or haven't been able to design our own experiment. They happen when, say, there's something that you think is harmful to people, and you're trying to prove it. And you're not allowed to just give the harmful thing to a random group of strangers to see if it hurts them. What you have to do instead is see who's already exposed themselves to this harmful thing and who hasn't. And it comes with huge problems. Sometimes we call these uncontrolled experiments because there's really no control. You can pretend there's control and pick people who haven't done the harmful thing, but you didn't pick groups. Give you an example. There is a strong correlation between diet soda consumption and diabetes. Adult onset diabetes. Kind that risk goes up if you're overweight and if you eat a lot of sugar. But they found that correlation not by picking a random group of people and making them, filling them full of diet soda, and picking another randomized group of people and not, giving them some placebo or something. That's not how they did it. They weren't allowed, right? What did they have to do instead? How do you study whether diet soda causes diabetes? Yeah. Yeah, or just ask everybody. Take a big group of people, find out how much diet soda they drink, and then see if the ones who drink lots of diet soda have more diabetes, right? But there's a huge problem with that. Anybody see it? What's the problem? These guys are choosing which group they're in already. They've already chosen. What's the problem? Have you ever been in line, McDonald's, behind a dude who orders like 3 Big Macs and a Diet Coke? Do you think there might be other choices people make that correlate with the choice to drink a ton of diet soda? What if people who order diet soda do it to compensate for the fact that they overeat? What if people who drink a ton of diet soda know that diet soda is probably not healthy and they also make other unhealthy choices, like smoking? You don't know. You don't know that the diet soda causes the diabetes just because there's a correlation. There could very much be other stuff going on. Now, I personally think maybe it does. Maybe that causation does exist. But it's really hard to prove, and they haven't been able to really clinch it yet, which is why you still see diet sodas and analytics, right? That's why it took so freaking long to get the warning labels on cigarette packs and to get tobacco regulated. Because, yeah, we knew there was a correlation, but it took a long time to prove that tobacco smoke does cause lung cancer. So it's really easy to show correlation. It's really hard to prove causation. Anytime it's an observational study where you're studying choices people have already made, you just never know what comes with that choice. You know, the tobacco companies were able to say things like, well, what if choosing to smoke also goes with, choosing to shoot up heroin? It's not the cigarettes causing the cancer. Correlation does not prove causation. You have to go a long way to prove causation. Here's a good example you've probably heard. 80% of car accidents happen within 10 miles of your home. You probably heard that before, right? What are they trying to get you to do when they tell you that statistic? It's the next thing they're going to say. Maybe. At least when I heard it, when I was younger, maybe they've stopped campaigning so hard because everybody already does this, but the next thing they would say is, buckle up, Ohio. Right? 80% of car accidents happen within 10 miles of the home. Wear your seatbelt. The implication being that you're less careful when you're close to home, right? You just go to the grocery store. It's fine. You know these roads, so you're on your phone, you're distracted, boom, you hit park, right? The implication is that this statistic shows you that people are driving less safely near home. That is not what that statistic means. It's misleading. You should wear your seatbelt. I'm not saying you shouldn't. I'm saying that statistic doesn't mean people are less safe near their houses. Raise your hand if you drive. What percentage of your driving would you say happens within a 10-mile radius of your house? It's a lot? Yeah, it's a lot, isn't it? I think the national average is like 90%. If 90% of your driving is within 10 miles of your house, but only 80% of accidents happen there, you're actually a little bit safer. That statistic doesn't mean what you think it means. All right, here's the really dumb one. It explains the picture. Throughout history, as the number of pirates has decreased, it has, global average temperature has also increased. Therefore, obviously, global warming is caused by a lack of pirates. How about you laughing? Right. My graph. Seems obvious. I'll go even further. Guess where most of the pirates are today? Yeah, and in one particular country has the most. It is Somalia. Yeah, you saw that Tom Hanks movie. Is that Tom Hanks? Can't remember. Yes, Somalia not only has the highest pirate count, but the lowest carbon emissions of any country. So here we get into what you're going to need to be doing. You already did it with the rich kids can't swim example. Try it here, and then I've got a worksheet where you're going to do the same thing. If it's not that A causes B, if pirates aren't causing, well, if lack of pirates isn't causing global warming, if the correlation of high number of pirates and low carbon emissions aren't related to that, is there a third thing in Somalia that might be causing both the pirates and the low carbon emissions? What does that mean, third world? We have lots of codes for this. Okay, we could say they're less advanced, or we might say, but what does it all really mean? What is third world and less advanced and blah, blah? Just means they're poor. Yeah, it's a poor country. It's a country where the people don't have a lot of wealth. And so you're saying what? Is that that's causing the other two things? Poor countries don't have as many carbon emitting things. You're absolutely right. Cars, factories, stuff like that. And do you think the poverty might be leading to some of the piracy? Yeah, you wouldn't want to be a pirate unless you really needed money, right? And they also just happen to have a nice fat shipping lane going by their country that they can get to ships that have valuable cargo. But yeah, you don't turn to that unless you really need money. Good. So there's a C there. A doesn't cause B. There's a C that's causing both A and B. Awesome. Here we go. Two scenarios. One ridiculous, one less so. First two questions for each scenario are easy. Third one, if you want to go. Okay. My friend who's a scientist wrote the top part. You don't have to read it. It's a little much. Just skip to the first graph. The first graph is about storks. A stork is a tall wading bird that hangs out in shallow water and eats fish and other stuff out of that water. And it turns out that and they went to 17 different countries in Europe. This is a real correlation. And you have to kind of, I'll just tell you that even though the data points look a little weird, the R value is high. That's the correlation that it is a strong correlation between human birth rate and the number of storks. Like, as in, the more storks there are in any given area of these of Europe, of these 17 European countries, the more storks there are, the higher the birth rate is. And obviously, that's got to be because storks bring babies, right? So, question one, A, I guess. Is that causal relationship we just proposed, is it biologically plausible? In other words, use your science common sense. Does that make sense to you? If the answer is yes, then in letter B, if it's plausible, how important do you think that relationship is? Do you think that A is the only cause of B? And skip that if the answer to A was no, obviously. C is where the real work and the real thinking comes in. Okay, fine. That's ridiculous. Do better. I need two more plausible explanations for why, because the correlation is real. It's true that the more storks there are, the higher the birth rate. Why would that be? You got to come up with two different explanations as to why storks and babies are correlated. Don't explain why one goes up without the other. They are correlated. Explain that correlation. Okay? So that's the first one. I love hearing your answers to that first one. You guys have come up with, I've done this for 5 years, I think, and I've heard such cool answers that I never would have thought of. Number two, though, this is the city obesity percentage in American cities. In other words, what percentage of the people are overweight? That turns out to correlate very strongly with the calorie content of the dessert recipes in that city's newspaper. In other words, the more like calorie bomb desserts there are in the newspaper, the fatter the people are. So obviously, newspaper dessert recipes are causing obesity. Now, again, letter A, is it plausible? Could that be happening? B, if so, do you think that's the most important cause of that thing? But then C, the most important, give me two alternative explanations. Correlation's real. It's true. The higher those dessert recipe calorie counts are, the fatter the people are. Why else could that be? Besides that it's the recipes causing people to be overweight. That one's tough for you. I have a hard time getting you to think in the direction we need to think on this one, because you're going to start going to things like that explain one of those two things but not the other. Explain the obesity but not the recipes correlating with it. There is a correlation. Explain why the two things are together. Is there a C? Is there a third thing that's causing both of them? Is it not A causing B but B causing A? These are all options, okay? So I'm going to give you the rest of the period, which is 15 minutes. I want you to get done with this, at least as much as you can. I think you will. But make sure your answers to C are strong, because we're going to talk about it in class tomorrow. I'm going to make you give me your answers once I check the paper. Okay? Good. Get to work. That was wrong.